Hey guys, Oric here, going over the Chapter 2 practice test for Prob and Stats. It's actually my second attempt at it here, so we'll give it another shot. So anyway, I will point out on here, there's a couple of questions that I pulled off the regular test, and otherwise this practice test is pretty similar to the actual test. And the only difference is, or like I said, I pulled a couple of problems off, and then most of the test is actually multiple choice, which I don't know if that really makes it any easier or not. But anyway, question number one, you got a bunch of, you flip a coin and it lands on tail a bunch of times. If it's a fair coin, the probability that you land on tails again is still 1/2 or 50% or 0.5. Any way you write these kind of probabilities is okay. What is the probability of getting a flush when getting dealt 5 cards? So this one is a little tricky because there's a difference between 5 cards all the same suit and 5 cards all the same suit if I said they all had to be spades. And the reason being is the first card can be any card at all. So the probability on the first card is just 1 or 100%, because it doesn't matter if you flip diamonds, hearts, clubs, or spades. But whatever card you flip, then the next card has to match the same suit. So the second card, there's going to be 12 of those cards left. You start with 13 of each suit. So there's 12 left, and there's only 51 cards. So it's 1 times 12 over 51, and then there's only 11 of that suit left in the deck, and there's only 50 cards left in the deck. And then there's only 10 of that suit left, and there's only 49 cards in the deck. And then there's only 9 cards and 48. And you multiply that out, and you end up with, if I did this correctly, 11,880 over 5,997,600. And that is approximately equal to 0.002 or 0.2%. All right, which numbers could not be the probability of an event? So the probability of an event, the lowest probability is 0, and it goes to 100% or 1. 0%. So you can't have negative percents, and you can't have anything over 1 or 100%. So this is all in numbers, so it's anything, this is okay, this is okay. You can have a probability of 100%. This is bigger than 1, so you can't have negative probabilities. Oh, nice circle. And you can't have negative probabilities again. Can be 0, it can't be 100 also. It can be 100%, but not 100. Actually circled that one wrong on my sheet here. Okay, question number 4. You roll 2 dice, 6 numbers on each side, on each dice. And what's probability of rolling a 7? Well, just remember there's 6 possibilities for the first dice, 6 possibilities for the second dice. We did a grid a bunch of times, so there's 36 total ways you can roll it. If you roll a 1 on the first dice, you can roll a 1 through 6 on the second dice. You roll a 2, then you can roll a 1 through 6. So there's 6 by 6 different ways you can roll 2 dice. So there's 36 total possible outcomes, and the number of possible ways to get a 7 is a 1 and a 6, a 2 and a 5. I think we've gone over this a couple of times here. And you can go all the way up, and if you roll a 6 on the first dice and you get a 1 on the second dice, that'll give you a sum of 7. So there's 6 ways to get a sum of 7. That was from the last chapter. And then there's 36 total ways that it can be rolled. So that ends up being 1 out of 6 of getting a 7. Kind of the same thing. I think there was a question on the homework that was, what's the probability of getting doubles? Well, there's 6 ways of getting doubles. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. There's 6 ways of getting doubles. There's 36 total ways. So there's same probability of getting 7 as there is getting doubles. Okay, here's a Venn diagram. So you can see some play football, some students play basketball, 17 play both. I think this was a picture out of the book. And then 21 don't play either football or basketball. So the total number of people that play football, basketball, both or none is, there's 84 total people. 84. And what is the probability that plays neither football nor basketball? There's 21 out of 84. Be careful on the test because I think it's the same question except how many play football and basketball, or what's the probability of playing both. It's 17 out of 84, not 17 out of whatever this number, 27 plus 17 plus 19 add up to. So 21 out of 84. The next question, and the numbers might be a little bit off on the practice test that I printed for you, but same questions. Bag contains some jelly beans. Here's the different colors. So there's a total of 18 jelly beans total. And I noticed my mouse clicks kind of loud, so hopefully that doesn't bug you too much. What's the probability of green? We have 5 green jelly beans out of 18 total. And if you just do 5 divided by 18 on your calculator, if the answer comes up as a decimal on your multiple choice, just do 5 divided by 18. If you pick 2 jelly beans and don't replace the first, so that's important, find the probability of getting a yellow, and then a second jelly bean's a yellow. So you pick one out, you eat it, and pick another one out, and you get 2 yellows. So the first one, you have 6 yellow jelly beans out of 18. And the probability of getting that next jelly bean, now it's multiplication, is there's 5 yellow jelly beans left, and there's only 17 total jelly beans. Now, if it's one of those questions where you put the jelly bean back in the bag, then it would be 6 out of 18 times 6 out of 18. And that comes out to be 30 out of 306. And the fraction could be reduced down, or as a decimal, it's approximately 0.098. All right, roulette wheel, which is my favorite, next to poker. So what happens on this roulette is you can Google it and you can see some in action, but probably not at school because they block most of those sites. But if you spin the wheel, a ball spins around and it lands either on red, black, or there's 2 green spots where the ball can fall. And then you can bet on, there's a board that you put your chips on, and you can bet on an individual number, you can bet on red, you can bet on black. That's kind of how it works. But it's almost 50-50 when you bet on red and black, because they're all, except for those 2 greens, throw the probability off a little bit. So what is the chance a ball will drop on green on the next spin? Well, there's 2 green, and there's a total of 38 slots. And that is 2 out of 38 or 1 out of 19. and that's approximately 0.053. What's the probability that red will be spun twice in a row? Well, now we have 18 out of 38, because there's 18 red. Of course, the probability would be the same for black, times 18 out of 38. And that is 324 out of 1444, or approximately 0.224. And once again, if you ever get this as a percentage, it's 22.4. So for a percentage, you always just move the decimal point over 2. Okay, number 8 here, the spinner. Now, number 8 is one that is, I believe it's a bonus question, or it was taken off the actual test. But I'll go through this here real quick. There's a spinner, so it's one of these kind of things with three spots, and there's 3 different colors, and a dice is rolled. What's probably you get green? So there's a 1. They're equal size, so you have a 1 out of 3 chances of getting a green, and a number greater than 2. So you can get the number 3, 4, 5, or 6. So you have 4 out of 6 chance of getting 4 out of 6 chance of getting a number greater than 2, which is 2/3. So if I multiply 2/3 times 1/3, I'm going to get 2/9. This is 4/18 if I multiply that, or 2/9, or 0.22222. I think that's 0.22222. Okay, next question. Try to keep rolling here. Yeah, this is the last question on the actual test, I believe. The numbers don't go in exactly the same order. Probability that both your cards are club, you replace it back in the deck. So there's 4 suits, so it's 1 out of 4, or 13 clubs out of 52. 13 out of 52 and 1 and 4 is the same thing. So it's 1 and 4, you put it back in the deck, so the probability stays the same that your next card is another club. So the chances that you get 2 clubs is 1 out of 16. 1 times 1 over 4 times 4. All right. Now this question is a bonus question on the test. I think I put 3 bonus questions on the test. So draw a Venn diagram. So you make a big box. There's 100 students total. So when we get all said and done with this, it should add up to 100. We have football players. I think we had one of these on the homework. I'll just put FB for football. And we have basketball, and some play both, so we have overlap. Put the both in first. That's really the key with this. 6 play both. And I'm going to actually do this. I'm going to go a different color just to show something here. So there's basketball. And 6 play both. Now, how many people play football but don't play basketball? Well, we have 27, because there's 33 football. 33 is the purple circle. It includes this 27, it includes this 6. That's why you put the 6 in the middle first. And same with basketball. There's going to be 12 people that play basketball only. And maybe that helps see that a little better. So you have a blue circle. Those are all basketball players. There's 18 of them. 6 of them play football also. And so we have 100 people total. So we have 100 minus 27 minus 6 minus 12. And that leaves us 55 in the neither. And you can just put a 55 out here for neither. So how many play football but not basketball? 27. How many do not play football or basketball? Well, we just figured that out, 55. If it was a probability, what's the probability that a random person doesn't play football or basketball? It'd be 55 out of 100. Okay, this pool ball scenario is on the test. Some of the questions I think might be exactly the same. There's 8 solid balls. Probably can see that better in the video than you can on the actual test. But the 1 through 8 are solid. 9 through 15 are striped. What's the probability that you get a ball that's solid? So 1 through 8 or a number greater than 10. So you have 11, 12, 13, 14, and 15. These are mutually exclusive. You can't get a solid and a number greater than 10 because all of the solids are less than 10. So we have probability of a solid is 8 out of 15, and number greater than 10, there's 5 out of 15. Or you could just add them all up. There's 13 out of 15. There's 13 balls that match that criteria, and there's 15 total. So 13 out of 15. Solid ball and a striped ball. Well, there's no ball that's solid and striped. So probability is 0. If I said a solid ball or a striped ball, then it's 100% or 1. Now solid and odd. Now solid, there's 8 of them. Odd, so we just want the solid and the 8. Or solid and odd. So we have 1, 3, 5, and 7. It's easiest just to count them up. 4 out of 15. On the actual test, I think it's solid or odd. Now that's going to be, now you're going to have some overlap. So you're going to have solid, just so you know, probability is solid. Just to give you a little clue, or odd. Now you have some overlap. Now you can count them up. Count up all the solids plus the extra odd ones. So there's 8, 9, 10, 11, 12. It's going to end up being 12 out of 15. From the formula, you got the probability of solid, which is 8 out of 15. I'm almost off the sheet here. Let me scroll it down just a little. Plus the probability of odd, which is also 8 out of 15. 1, 3, 5, 7, 9, 11. That's 8 out of 15. That gets added together, and then we subtract off because we've counted solid oddballs twice. 1, 3, 5, and 7. So minus 4 out of 15. And that adds up. 16 minus 4 is 12 out of 15. Sometimes if you don't have the picture right in front of you, this probability of the first plus probability of the second minus the overlap. And this question is also on the test. And I think the probabilities stay the same because I think I used the same picture. So the probability that Johnson wins the first is 59%. That's 0.59. And the probability that he wins the second time is 0.48, so the probability changed, but home court advantage or something. But if you notice, Johnson and Henderson, when they play the first game, so this is the first game, Johnson's got a 59%, Henderson's 41. So one of the two is going to win. You add it up, it adds up to 100%. In the second game, if Johnson won the first one, it's 48 and 52. Now, that adds up to 100%. This adds up. Everything always adds up to 100% each event. So, we have Johnson. If for him to win 2 games, it's going to be 0.59 times 0.48. Let me erase that. Let me do it this way. Times, I'll do times with an X here, times 0.48. And that's 0.2832. And I'm using 4 decimals just to show you that it all adds up to 100%. Johnson, Henderson. No, this should be probability of Johnson. It's 0.59 times 0.52. 0.52, which equals 0.3068. Now we did one that was like everything is 50%. I think one with the basketball free throws, it was 70. It always stayed 70% and 30%. This one, the probability changes, but you just do the same thing. You just multiply each branch of the tree, so to speak. Henderson win the first one, Johnson wins the second, so Henderson, Johnson. And that's probability of Henderson winning the first match is 0.41. Johnson winning the second match is 0.48. And that's 0.1968. It's kind of a good way to see if you did it right. And then the last one, Henderson. I'm going to move myself over just a little bit to the left here since I'm running out of room. That comes out to 0.41 times 0.52, which equals 0.2132. I think that's what it is. I wrote it kind of sloppy on my sheet. But if you add these 4 numbers up, it should add up to 1. It should add up to 100%. To answer the question, what's the probability that Mr. Johnson wins only 1 game? So that's the tricky one. It's 0.3068 plus 0.1968. And the reason you're adding here, most of the time you multiply. But you have Johnson, for Johnson to win 1 game, it's either going to be Johnson Henderson or, and when it's or, you add Johnson Henderson or Henderson Johnson. So you add these 2 probabilities together. Just like all of them all together add up to 100%. So either this is going to happen, either Johnson wins 2, or Johnson wins first, Henderson wins, or Henderson Johnson, or Henderson Henderson. Those are the 4 total possible outcomes that you can have. And then this comes out to be 0.5036. About 50% after all that's said and done. The probability is going to win 1 and lose 1. If they ask what's the probability of Johnson winning 2, it's just 0.2832. Johnson winning 0 or Henderson winning 2, it's 0.2132. And that is the last question. So I'll end it here. Have a good one.